So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So the main agenda for today's session is to discuss on the statistics and probability as an integral part for data science. So the main agenda for today's session will be discussing on what exactly data is, what are different categories of data, what is statistics, what exactly are basic terminologies used in statistics, what are different sampling techniques available, what are different type of statistics, what exactly we mean by descriptive statistics, probability, and inferential statistics altogether. Now, again, guys, this session is highly theoretical because here we don't have any tools or any particular platforms to work on. So here, the main motive of this entire session is to have a clarity on the concepts of data and how data is, and then the statistics and probability which we need to use as a part of data science. And that's why the entire session is highly theoretical as of now. Now, first of all, let's understand what exactly data is, right? So data simply refers to facts and statistics collected together for references or analysis. So data can be in different formats. Data can be originated from different sources, right? And in different frequencies and different varieties, right? So the data can be in any format. Data can be from any of the given sources. It can be in any given format possible, right? So data can be, now, first of all, when we have any source of data, for example, if we have YouTube, if we have social media platforms, if we have data stored in any kind of databases, right? So these all are different sources of data. So first of all, again, there are three sources. Now data can be collected here, then again it has to be measured, and then it has to be analyzed as a part of successful data scientists, right? First of all, we have to collect the data, then we have to measure data, and then we have to analyze it, right? And then we have to visualize the data as well. When we talk about data sets, it can be in any given format. It can be structured, it can be unstructured, it can be in different formats as well. So based on the given formats, we have to choose the best format that we need to use it in to make sure we do get the answers to the questions we are looking for. We're trying to solve here. Right, and now let's understand the different categories of data. Now, in terms of data, when we are working as a data scientist, now there are basically two main categories of data. We have qualitative data and then we have quantitative. So qualitative and then we have quantitative data available to us. And now in terms of qualitative data, then we have nominal and then we have ordinal, whereas in quantitative data, we have discrete and then we have continuous data with us, right? So these are different categories of data, one divided on terms of quality and the other one divided on the terms of quantity. Again, when we start, again, if we start our journey in data science, and again, it as a part of prerequisite or as a main skill set required to excel in the field of data science, we should be good in statistics. That means we should be good in handling numbers and we should be good in handling data sets, right? And statistics offers multiple models, multiple techniques through which it can become much easier for us to make sense out of any given data here, right? For example, suppose if a company has created a new drug, right, that may cure the cancer. Now how would you conduct a test to confirm the drug's effectiveness, how effective it is, or whether, or suppose if it is not effective, then it should be going back to the table, or again it has to be completely dropped down, right? So again, in order to perform the complete analysis here, again we need to have statistics, right? Again, in second use case, suppose if we and suppose if you and your friend are at a baseball game, right? And out of the blue, he offers you a bet that neither team will hit a home run in that game, right? Now, should you take the bet based on the complete logical part, right? That is a question answered by statistics. And same way as a separate use case. Now the latest sales data have just come in, and your boss wants you to prepare a report for management on places where the company could improve its business. Now, what should you look for? What should you not look for? That means again we have to segregate what kind of data we need to require, or what kind of data will give us the answer, or what is total base for us. We have to make the call there, right? Now, let's understand the basic terminologies used in statistics, right? Now, suppose if we have the entire population with us and we have, again, if we pick any given population, right? Now, then we have population simply refers to a larger set of data. For example, if we have data for 10,000 patients, right? Now, out of those 10,000 patients, we have picked just 1,000 data with us, right? That means 1,000 is a sample data on which we want to perform the complete statistical analysis on. That is what we refer to statistical term like population and sample. So population refers to the entire data set. For example, if we have 100,000 website visitors, right, and we want to analyze almost whenever we take a portion for our analysis, then that smaller portion will be considered as a sample data set. And why we are discussing this? Because again, there are multiple. Now, these terminologies, these are common terminologies used frequently in the field of data science, right? Now, let's understand the concept of different sampling techniques here. Now, in terms of sampling, we have two types of sampling offered. We have probability and then we have non-probability. Now, first of all, in sampling, let's understand these concepts first. Now, here in sampling, we have two things. We have probability and non-probability. So in probability, we have random, stratified, systematic, whereas in non-probability, we have snowball, judgment, convenience, and quota. Right? Let's understand these step by step. So first of all, let's understand on the random sampling. So now random sampling, systematic sampling, and then we have stratified sampling. So random is, suppose if we have a larger set of population, then without performing any kind of logic, we can choose any given sample randomly from any given audience size, right? And then systematic sampling is, now for suppose if we have multiple groups of individuals, right? For example, we are conducting analysis on the behavior of, suppose if for users for designing any given application, right? And we have 6 user groups for that, right? So what we can do from now, one user we can pick from the teenager group, one user we can pick from the youth, those who are falling from 20 to 25. Another user we can pick from 25 to 30. Another one we can pick from 40 to 45, 45 to 50, and 50 and above, right? So that we have some common use cases, we have some common individuals that we have systematically picked from each and every category of our data. And then we have stratified sampling. So stratified sampling, when we talk about stratified sampling originates from stratum. So stratum is only a subset of population that shares at least one common characteristic. And in this case, it is gender. For example, here we have male subset and we have female subsets, right? So suppose if we want to perform some analysis, that again, some random people will be brought up from male and again same from female, right? And then we perform the analysis on the further stratum shade there. Now to understand this in simple layman terms, let's do one thing. Let's go back into our Picasso mode to understand this in simple layman terms. Now, for example, we have a data set with us. We have a small data set with us, right? Suppose if we have one data, we have a population with us, right? Suppose let's say if this data belongs to 100,000 of users. Now again, kindly excuse for this beautiful calligraphy, guys, because that's what happened when we try to write using our mouse pointer or our touchpad, right? Suppose if we have data for 100,000 users, right? Now, first of all, in random sampling, what will happen? We will pick random data, or suppose we can say random group of users from this data set. Now, when we are picking randomly, we may pick 1,000 only men, right? Or we may pick 500 men, 500, or suppose 400 women and 100 children, right? We may pick, suppose everyone above 50 years of age, right? We may pick a simple group which will contain 30% youths and 50% above 60 years of age group, and rest of the 10% in the middle age area, right? So random selection is done on a complete random basis, or we can say random sampling simply refers to picking up random data set without any kind of logic in between, right? That is what we refer as random. Now, coming back to the concept of systematic is, now in systematic, what happens? Suppose in systematic sampling, what we did, we simply divided the entire sample. Suppose if we have 100,000 population with us, right? So in systematic, what we did, we divided them on the basis of gender, that is and female, male and female here, right? Again, there are no further category, there are no further subcategories required here. What we had, we have simply divided them on the basis of the gender group as a part of systematic sampling, here, right? Or or it can be based on age group, or what we have done in terms of systematic is, suppose we had divided them into 5 equal groups, right? One is based on, suppose, car, or suppose let's say over here we have race, right? Suppose one are based on race, right? One group is based on region, right? One group is based on the age, or one group is based on, suppose, gender, right? Now, or suppose they can be further subcategories as well. So what we are doing, suppose let's say we have 5 different activities. We have divided the entire audience into 5 different kind of activities as well. For example, racing and trekking and suppose swimming. So again, based on their activities, suppose if we have 100 users in each and every group, suppose if we have 1,000 users in each and every group here, then we do pick, so then we have a logic. Suppose here we are picking every fifth individual from one particular group here. So that this is all systematic sampling that we are going for, right? Where stratified is, we can divide it into multiple age groups. For example, in age factor, what we can do, we can simply create multiple subgroups. For example, those who belong from 20 to 25 years of age group, those who belong from 29, so suppose from 29, from suppose 26 to 35, right? So depending upon our age group, we can define the same audience, we can segregate them, right? Now let's understand the type of statistics. So basically we have, first of all, we have descriptive statistics. So basically here we use this for describing the population, that means giving attributes. Suppose if we want to define maximum value, average value, minimum value for any given population, then we can use descriptive statistics for that. We can use descriptive statistics for that purpose, right? And then we have inferential statistics. So inferential statistics basically interference with the predictions about a population based on some sample data, right? So for example, suppose if we have large, medium, small set of data with us, right? So basically now, in terms of inferential here, we simply take we can say a sample out of the entire population. We take care of the entire statistics of that particular sample that we have chosen, right? And again, we simply deduce from the finding of that particular sample and apply to the entire population altogether, right? So basically what we are doing, we are simply performing the analysis on a given data set from the entire population, and then we are generalizing it for the complete bigger group here as a part of inferential statistics, right? Now let's look into these two main components in deep, what exactly these are and they contain. So first of all, we have descriptive statistics with us. Now, when we are talking about descriptive statistics, now this is what we have already studied so many times into our school days as well, starting from our school to college, right? So for example, suppose if we have multiple, we mainly have two main different categories available in descriptive statistics. We have measures of central tendency, and then we have measures of variability, right? So in measures of central tendency, we have three main core components of statistics. We have mean, median, and mode. So as we have studied so far, as we may have studied into our school days, right? So we have three main core components for any given measures of central tendency, we have mean, median, and mode, right? And then in terms of variability, we have range, interquartile range, variance, and then we have standard deviation. I believe most of you must be familiar with the concept of standard deviation as a part of the entire learning model. This is what we have, majority of us have studied in our school and college days. So first of all, let's look into measures of central tendency. For example, now for understanding this in simple layman terms, let's look at this given data with us. So we have the list of cars, the miles per gallon average, that is the average, the number of cylinders, the displacement, the horsepower, and the traction, right? So again, these are the main components for any particular car here, right? So here we have now this data here contains a list of cars again and everything inside it, right? So now if we are considering, if we do consider something as mean here, so what we can do, we can simply take the mean of the horsepower, we can take the mean of the mpg as well, right? For example, as a small example here, for example, let's say we want to find the average horsepower for the given list of cars, then what we can do, we can simply total the entire sum, can total the entire sum, and then we can divide it by the number of participants here, right? So here, as you can see, 110 plus 110 plus 110 plus 110 plus 110, right? And then he got 93, 96, and 90. So for example, suppose if we have these kind of data set with us, now in order to find the mean, what we have to do, we have to find the mean of the entire HPs here, right? So we simply have to add all of these and then divide it by the number of data that we have taken a look at. For example, if there were 10 different members here, there were 14 other members here, right? So again, then we would have required to add up those 14 members and then we would have simply divided that. And median, as you know, is the average, or we can say we can say the most popular value given from any particular data set here. So suppose if we have different data sets here, for example, if we have data sets for, we want to find the median value for the miles per gallon. Then as you can see here, the most popular value here is 22.9, which we can derive by dividing we can say we can say two middle values, and then we can get the average, or we can say the most popular value from the given data set that we are looking at. And the most recurrent in the entire sample set is known as the mode altogether, right? For example, if you want to find the most common type of cylinder, again we can see it is 6 in the given data set as a part of mode, right? And now in terms of measures of spread, we have first of all range. So range is simply how spread apart the values are in data set. For example, if we talk about the previous data set here, then what is the maximum and minimum value, and then how we have to extract data on top of it. In terms of range, right? Suppose if we want to find the range for displacement here from HP here, then we can simply deduct the maximum value, and then we can deduct it from the minimum value altogether, right? And then in terms of the interquartile range here, so again, quartiles simply let us know the spread of data. That means how widely a given data is spreaded, right? So now for doing that, what we can do, we can simply divide them into multiple quarters, or suppose in 6 different components here in multiple quarters, just like we have median. So median simply divides it in half, whereas interquartile range simply divides the given data sets into into given quarters here, right? As you can see here, now here we have the entire data set for 100 students here, right? So here we can find in terms of the first quartile. So again, there's the first quartile here. Now it lies between 25th and 26th, being the first quartile here, first quarter, right? So here we can find the average value. Then second quartile will focus on 50th and 51st. Third one will be 75th and 76th, and fourth one will be 99 and 100, right? So that's how that's how the interquartile range is spread in any given data set, right? And that's how we are divided here. So interquartile range is simply the range between the 3 different quarters. Then we have variance. So variance focuses on how we can say how the entire data is divided. Okay, how frequently it is, if we can say how much it is deviating from its expected value, right? So here we can simply define this by a simple component here. So here we can take into consideration individual data points, and then we can divide that by total number of data points, and then we can get the mean out of it. Then we can simply calculate the mean of the given data pointers here. And then standard deviation is simply the difference between each element from the mean altogether. And a small use case, suppose if we are talking about standard deviation, then Daenerys has 20 dragons. Now they have the same numbers. If they have same numbers as 9, again, these are different given numbers for the dragons here, right? Now, if you want to work out on a standard deviation, then the entire mean is what? 20. So again, we have to find the entire sum of the individual numbers and then divide it by the total number of given sets here, right? And then here we can find the entire mean, right? And then to find the entire standard deviation here, what we can simply subtract the values here. That's 9 minus 7, 2 minus 7, and 5 minus 7, right? And that's how we can get the individual values for the given components here. So as you can see here, for the given set, what we have 9, right? So here we have to write 9 plus 9 minus 7, then 2 minus 7, 5 minus 7, 4 minus 7, 12 minus 7, 7 minus 7, 8 minus 7, and so on. Then we have something as information gain and entropy. So in terms of entropy, it simply measures the impurity of, or we can say uncertainty of the amount of the data that is present in any given data set, right? Whereas in information gain, again, simply make sure that the information of a particular feature or variable give us more about the final outcome, right? And again, entropy focuses on, again, for finding any kind of uncertainty. Suppose the entire data is ambiguous. All right, so now in case we are all clear on whatever we had discussed so far, now let's understand a small use case here. Now, for example, forecast whether the will be played or not according to the weather conditions, right? So now, based on the previous data that we have acquired from outlook, from humidity, wind, and again whether we should be able to play or not, right? So again, these are different data set provided here, and the next one, now we can simply predict the actual weather, right? Again, and that too in the best possible manner, in the best possible manner. All right, so now in terms of the use case here, what we are done, we are now in terms of the outlook, then here we have three different outputs with us. We have sunny, we have overcast, and then we have rain. So what we have done, we have simply divided this into smaller components as sunny, outlook, or rain, right? Then now in these 14 different instances that we have currently performed our analysis on, 9 said no and then 5 said yes itself, right? And then we can perform the entire entropy analysis here, where we can divide the number of times again by the respective agency altogether. Okay, now let's understand on the confusion matrix. The confusion matrix here is simply a table that's used to describe the performance of any given model, right? Or suppose let's say we want to find, now this is basically used in the classification algorithm as a part of data science. This is basically used as a classification for classifying data in data science field here. So here we can divide, here we can first of all add up the true positive and true negative, and then we can divide this from the again the same addition of the negatives plus again false positive plus false negative as well, so that we can have a good visibility in terms of confusion matrix. Now, next is we do have some kind of confusion matrix, right? So confusion matrix that we have studied here. Now let's link it up to a small use case. For example, now there are two possible predicted classes here, yes and no, right? And again, the classifiers are made of 165 predictions. Now, let's first of all, let me show you what exactly the problem statement is. And same way, in reality, there are 105 patients in the sample that have a disease, whereas in 60 patients, they do not. 60 patients do not, right? So number of patients in total, we have 165. Now they predicted no, the actual number was 5, right? And they was, and in reality, they was yes, right? Whereas in terms of the prediction, if they predicted yes, they didn't have the disease, then it was 10, right? And when they predicted yes, in reality, it was yes, that was 100, right? And that's why the concept of true positive, true negative, false positive, and false negative comes into play. So true positive refers to the cases when we predict it comes yes, right? Then true negative is when we predict no, we don't have the disease or any kind of output. Then in false positive is we predicted yes, but again they don't show they actually have the disease itself, right? Same as false negative is when we make multiple predictions on no, but again, they actually do have the disease, right? Then these are considered as an error, or we can say as a part of false negatives, as a part of false negatives. So false negatives and false positive, they both are considered to be an error here, right? Now, next is we have the concept of probabilities, right? So again, here we simply define the number of outcomes, which has to be divided from the desired outcomes, right? Suppose if we are rolling the dice here, right? So whenever we roll the dice, we get 6 possible outcomes, and the possibility of every single outcome is 1 by 6, right? Suppose the possibility of getting 2 is 1 by 6, the possibility of getting 3 is 1 by 6, right? And so on, right? So probability is simply finding the possibility of occurrence of any given event, right? And in terms of the common terminologies we use in probability, we have random experiment, we have sample space, and then we have events. So random experiment involves, now random experiment is simply a process where the outcome cannot be predicted with certainty, right? And then we have sample space, and then we have event type, right? So again, in event type, suppose the entire possible set of the outcome again is a sample space for that particular experiment. Whereas in events, one of the more outcomes for an experiment, it is a subset of a given sample space that is considered as an S here. And then we have disjoint, and then we have non-disjoint events as well. So disjoint is when they are again when they are some kind of overlapping, right? When there is some kind of overlapping, and again in non-disjoint events happen when they don't have any kind of overlapping or any common data set with us, right? And again, for example, a simple use case is now when we have disjoint events, for example, we have one event for 6 and one event for wicket, right? So again, they cannot be overlapped. So again it may be a 6. Like again, if it is a 6, it cannot be a wicket. And again, if it is a wicket, it cannot be a 6. That's why these can do different data joints cannot be overlapped, right? A single card drawn from deck cannot be a king and queen both. It cannot be possible. Yes, in case it would if it would have been a king, right? Then again, suppose if we want this to be in specific colors altogether, right? Then that would have overlap. Then that would have overlap, but not king and queen both, right? A man cannot be dead and alive both. So again, these are considered as a disjoint events when there is no possibility of one event overlapping with the others, right? And again, non-disjoint event is same way. If we have kings, again, then in specific color, right? If we have students who are getting 100 marks in stats and 100 marks in probability, it can happen, right? And the outcome of ball delivered can be a no ball and be a 6, right? Again, it can be a no ball, it can be a 6 as well. And that's where they will be overlapping on. And then we have probability distribution. So again, in distribution, we have three things. We have density function, then we have normal distribution, and then we have central limit theorem. Now, as per the definition goes, the equation describing the continuous probability distribution is called as the probability density function altogether, right? So for example, suppose if we have property 1, the graph of PDF will be continuous over range here. In property 2, again the area bound by the curve density function is equal to 1. And the property 3, again the probability of a random variable assuming a value between A and B will be much higher. And then we have standard deviation and curves. So again, the graph of a normal distribution depends upon two factors. We have mean and then we have standard deviation. So mean, it simply determines the location of center of the graph that we have discussed already. And standard deviation simply determines the height of the graph itself, right? Means how much deviated it is from the normal distribution altogether, right? And then let's discuss the types of probability. Now, in terms of the types of probability, we have three main types of probability. We have marginal probability, we have joint probability, and then we have conditional. Marginal, joint, and conditional probabilities. Now, let's discuss what exactly these three are step by step. So, marginal is simply the probability of occurrence of a single event. For example, what is the possibility of finding three here? So again, there are three. There are again the possibility of finding three, and again, red heart says 13 by 52 being the occurrence of a single event, right? Then joint probability is simply is a measure of two or more events happening at the same time. What is the probability of finding three spades or four spades in a game itself? Of suppose four aces in a game, right? Again, then we can find this as a part of joint probability, right? And then we have conditional probability where the probability of one event depends upon the occurrence of a previous event or outcome, right? So for example, when we roll a dice, and again, when we are rolling two dices, if suppose if we are finding the possibility of finding 13 in total, right? Then the possibility of the other event of the other dice number will be dependent upon the previous one, because then only if two dices are again in the same proportion, then only we'll be getting 13 as an output. Or suppose not exactly 13, but again 11 or 12. Again, what exactly we are looking for, that will be a part of the entire dice status. And that will be a simple example for conditional probabilities. And a simple use case for this one can be different salaries. Suppose if we are going for training and salary packages of candidates, right? This now we are taking a sample of 60 candidates without training and 45 candidates with Edureka's training, right? And here the task to do is assessment of training with salary packages offered for these individuals, right? 60 without and 40 with training, right? Again, training without Edureka training, again, very poor package, 5. Again, poor package, we have 10. Average package is 10. Good package, we have 30. For with Edureka training, excellent is 5. And that's how we have the total number of packages with us, right? And suppose same way we have to find the probability that a candidate has undergone an Edureka's training, then what we have to do is we simply have to take into consideration that again, now this is a conditional, a simple conditional probability, right? So again, here we can find the probability of educational training by the total number of participants, right? Divided by the distribution for these, right? As in the total number of participants here, that is 105, and that will be 0.42. And same way, if we had to find the probability that a candidate has attended Edureka's training and also a good package, then in here we have to simply divide the good package plus with training and without training, right? And then we have to divide by the total number of packages, right? There's 30 is the common, right? And then we have the total number again as 105. And again, for those students who are having a good package with Edureka training, right? Good package with Edureka training by the number of total participants here, right? And then at last we have to find the probability that a candidate has a good package, but again, he has not undergone the training part, right? Then how much we have? We have 5, and then we have the total number of participants by 60. That is 0.08. So there's only a probability of 0.008. That is only 8% that a person will be having a good package without going for any form of training altogether. All right, guys. So I guess it's almost time now. So thank you so much for being a part of this entire session as well, guys. And have a great day ahead. Take care. Bye bye.